there are a lot of things you have to understand before you get started with Spark hands-on. Writing Spark programs are actually very easy. It's not so difficult to write a program, then run it and get it. That's not what is difficult. What is actually difficult is to understand what is happening behind behind the scenes, right? Okay, so I have connected with you know the VM. Now, one thing you need to understand is that Spark offers an interactive shell in Scala, Python, and R. So if you want to program in Spark, you can open a shell and then type your stuff, right? Very much like you were doing in the Scala world. You were opening the Scala prompt and then you were typing stuff, right? Now, the second thing is that Spark also allows you to package your source code and run it. So this is the second way. So one way is that you open a shell and then type your code step by step, blah, 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 right? The second thing is that you can also write your entire source code in a file, then compile it, package it, create a jar file and run it. I will show you both things, okay? But most of the times we will be working from the shell. And that is the easiest way to understand Spark. If I go to the packaging mode, I will have an application which will get packaged. And I can show you how to run that, but you may not be able to understand everything, right? So most of the time, we will prefer the shell, at least for learning Spark. Once you master Spark, if somebody asks you to create a Spark application or something, you can write a code and package and give it to them. Now, the next question is that how to start the Scala shell for Spark, right? So I want to use Scala. Obviously, we know Scala. Now, we know that there is a Scala shell. Now, how do I start it? What is the command or how do I start it? And what are the things which will happen, right? So now starting this is okay, but then still there are a couple of things you need to happen. The command is spark -shell. This is the command. So you have to type a command called a spark -shell and then Spark will start in the Scala prompt. Now I can show that if I go here, I'll simply type spark -shell. That is a command I wrote in the one notch. I hit enter, Spark will start. Just wait for a moment. Yeah. See, so when I type the command spark -shell, it started the shell. And there are a couple of things you have to make a note of when you are starting the Spark shell, right? So one thing is that you can see the version of Spark. It clearly says that the Spark version is 1.6.0 and the Scala version is 2.10.5. So these 2 points you have to make a note of. And in your VM, when you start, I don't know whether you're having the same version. Maybe you have a different version. But it is fine. You know, the versions are fine. You don't have to really worry about them. Maybe you will run 163 or 15 something. But when you start this Spark, you will be able to see this version number. And also what is the Scala version Spark is using. Now, Spark has two major releases. Okay, so Spark has two major releases. They are called a Spark 1 and Spark 2. We are on Spark 1, and there is a reason. Okay, Spark 2 is quite new, even though Spark 2 is very stable. If you look at the industry, right, most of the companies are still using Spark 1. They have not migrated to Spark 2. And there is, from command wise, let's say you are learning your commands or the program, there is only a slight difference between Spark 1 and Spark 2, which means whatever you are learning in Spark 1 will easily work on Spark 2 as well. So you don't have to really worry about the syntax or the commands and all. However, Spark 2 has a lot of performance improvements compared with Spark 1. It is actually better, but I don't want to use it because as of now, most of the industry is on Spark 1.6, and this is a very stable version, right? So we will learn this, and whatever you have learned, you can use them in any other Spark version as well. Now, if you want to understand the versions, just go to spark.apache.org, and if you go to the uh, documentation, there is older versions. Okay, and these are all the versions we have. We are on Spark 1.6.3. Okay, after that there is 2, 2.1 and 2.2 as of now. Okay, however, any Spark 1 is perfectly fine with us just to learn, right? So this is another point which I just wanted to clarify. That is why you see a 1.6.0. Even this is my virtual machine. Even your VMs will have one of the Spark 1 versions. Okay, and then it starts. And how do you know whether Spark has started or not? Is that you will see this Scala prompt, right? You will see this Scala prompt. That means Spark has started in the Scala interactive mode, and you can start typing your code or whatever you want. Okay, and you can simply type an exit, and you will exit from the shell, right? So if you simply type exit, you will exit from the shell. Okay, so I will again start the shell because I just closed it. Okay, now one thing you need to understand is that if you want to work with Spark, you need a driver program. So any application, you need a driver program, right? So even with Spark, let's say you want to work with Spark, you need a driver program. By default, your shell will become the driver program. So when you start the Spark shell, the Spark shell will be your driver program. So you don't have to create a driver program. That's my whole point, right? Whatever you are typing, your shell will interpret and make sure that it will run. So you don't have to worry about a driver program while starting the shell. The shell will become your driver program. Okay. And the next thing is that in Core Spark, there are three building blocks for your program. Meaning, when somebody is creating a Spark program, there are three things which are very, very important. Okay. One is called something called Spark context. Second is called RDDs. Third is called transformations and actions. So these are the three things you must have if you're creating a Spark program. Okay. So in this, the first thing is called the Spark context. What is this guy, right? This is an object used to access Spark libraries. Okay. So what is Spark context? Spark context is an object. Okay. And when I say it is an object, what is the purpose of this? See, we just started Spark, right? So here you have the Spark shell, right? And this is a Scala prompt. So if I type something here, what will happen? My Scala will interpret the code for me, right? I type anything. I say, for example, I type 1 plus 2 or anything. What will happen? I will get the answer, right? So let me just show you this. See, if I do a 1 plus 2, okay, my answer is 3. Okay. Now, do you think Spark is running this code or Scala is running this code? What do you think? I typed 1 plus 2, I got the answer. Again, I say 5 plus 5, I got the answer. So, who is running this code, Spark or Scala? It is Scala, right? It is just a Scala shell, and you are getting the answer from Scala. So, now the question is that this means if I type anything here, Scala will execute that for me. I don't want that. I want Spark to execute my code. Spark is already there, but I want Spark to run my code. So how do I tell that, hey, Spark, run my code? That is using this thing called Spark context. It is an object. So you have to use this object whenever you want to access Spark from the shell. So this is the entry point to the Spark libraries, right? And I will show you this. So now the next question will be that how do I get this object? You don't have to worry. When you start the shell, it will be written here somewhere. See? Spark context available as SC. So what will happen when you start the shell will create something called Spark context object as SC. That means if I call this object with SC, the name SC, I can connect with Spark library. Anything I want to do with Spark, I have to say SC dot. That is how I access Spark. All the Spark method, functions, anything you want to access, first time you have to use SC. Otherwise, your Scala will execute it, right? And that is something we don't want, right? We don't want Scala to run our program. We are just using Scala. We want Spark to run our program. And that is why we are using this SC or Spark context, okay? The next point is that Spark shell can be started in two ways. Okay, there is a local mode and there is a yarn mode. Okay, so when I say I'm starting Spark or the Spark shell, right, it can be started in two ways. There is something called a local mode and then there is something called a yarn mode. Okay, so what is local mode? This is the default mode. That means we are in the local mode. We started Spark shell. We are in the local mode because this is the default mode. Here, okay, Spark will run locally on the machine. It will ask the OS operating system to get the resources. Okay. Also, entire code will get executed within a single JVM normally. So what is local mode of Spark? What we started right now is the local mode. This is called the local mode. When you start Spark in the local mode, it will start on the machine. So right now the virtual machine, right? And it will start and it will ask your operating system for the resources. For example, right now I have a Linux as my operating system. It will ask the operating system, hey, give me some resources to run this Spark program, right? And the local mode, and this mode will work only on a single machine. That is the point. Local mode will work only on a single machine. You cannot expand it. Then why do you need the local mode? For testing, development, and learning. So if you want to learn Spark, probably the best way is the local mode, right? What is the yarn mode? Here, Spark will use yarn to allocate resources and run the code. This means it can run the program in a cluster that is hundreds and thousands of machines, right? So when you start the Spark shell in the yarn mode, I will show you how to do that. Okay. What will happen? Your Spark will register with yarn if yarn is available, if you have Hadoop. So Spark will tell yarn that, hey, I am Spark and I want to run the program. So yarn will say that how much resources you need. Spark shell will probably say that I need 100 machines, and yarn will give you 100 machines. So that is the cluster mode. Okay. So the production mode is the yarn mode, but for learning, local mode is fine. In fact, both the modes, while running the commands or syntax or anything, both are exactly same. You will not even see any difference, right? Only difference is in the execution. Yarn mode is used if you are having a cluster, because in a cluster, if you want to utilize the full power of a cluster, you need a resource manager, and that is your yarn. Remember how you can run a Mapreduce program? If you submit a Mapreduce program, your yarn's resource manager will pick it up and run it, right? Same way, your Spark shell can register with your resource manager, and it can run it on a full cluster. The yarn mode can run on a single machine also, and that is what I will show you. Okay, so we are in local mode right now. So that is one thing you need to understand. We are in the local mode. So now what we did, we started the Spark shell and blah, blah, blah. Also, one more very interesting thing you can note down here is that when you're starting the Spark shell, it says Spark context available as SC. It also says master equal to local. Very interesting stuff. So this is how you understand that it is in the local mode. Master is in master equal to local means you are starting Spark in the local mode. Otherwise, how do you know, right? And I will explain what is that star means later. As of now, don't worry about the star. Okay. So while starting the Spark shell, you can clearly see master equal to local, right? Now, one more thing is that in local mode, Spark UI will be available in IP address colon 4040. So Spark has a UI, a user interface, okay, and you can easily see the UI if you type the IP of the VM and the port number 4040. Can I show you that? Yes. So if I open my VM is 131, and simply type 4040. That's the Spark UI, right? What you see here is the Spark UI. And as of now, you are not seeing anything, because the Spark UI will display something only when you execute something. Remember, Spark is very, very lazy, right? So you have to write some transformation and action. And when you call an action, then only it will display something on the UI. As of now, there is nothing. There is something called stages and storage. I will explain all this later. You can see the environment where you see the Java version, Spark version, and all, and executors, SQL. Nothing much to see right now. Anyway, right? So that's the Spark UI. Now, um, the first thing that you should learn in Spark is how to create an RDD, right? So, how to create an RDD, right? So, there are two prominent methods to create an RDD. One, you can create an RDD from an existing collection. Two, you can create an RDD from an external file. So there are two ways to create an RDD. The first way is that you can create an RDD from a collection. What do you mean by collection? Say you are having list, array, anything like that. So you have an array, you have a list, and you want to create an RDD, you can do that. So here you will use a method called parallelize. Okay, so parallelize is a built-in method. Okay, and you will use this method if you want to create an RDD from an existing collection. To give you an idea, okay, val a equal to sc dot parallelize 1 to 1000. I just created my first RDD. How did I do it? Well, first thing you need to understand is that the name of your RDD is A. You can give any name you want. So the name of the RDD is A. Second thing you need to understand is that I am saying sc dot parallelize. So remember what is sc? Sc is your Spark context. So you have to talk to Spark library to create an RDD. So you will say sc dot parallelize is the function which will create the RDD. And this is my data. My data is nothing but numbers 1 to 1000. I just want to convert numbers 1 to 1000 into an RDD called A, and this is how I do it. So I will type the commands in here so that you will understand it. Okay, and you can clearly see that Spark says A is an RDD of integer type. So there is automatic inference. It says that we have created an RDD and it is of integer type. Now, second thing you need to understand is that in an RDD, Spark always treat it as a collection of elements. For example, here you are saying that I have numbers 1 to 1000. Okay, fine. This means what Spark will understand. Spark will understand that the RDD has 1000 numbers and each number is an element. That is how Spark will treat it. Now, if I look at the UI, Spark UI, I will not see anything here because I have not called any action. I just created an RDD and nothing will be displayed here. If I want to see something, I can do an a.collect. Collect is an action. Remember in the slide also I had explained about collect. Collect is an action, and what collect will do, it will simply display the output, or it will simply display the content of an RDD. So right now I am saying that, hey Spark, display the content of A. And Spark is very intelligent. It will not display all the data. It says 176, so on and so forth. I mean, etc., etc., right? And the results are always displayed inside an array. So this array is default. Spark will create an array and throw the result to you. So we see very interestingly that we called an action a.collect, and then you can see the output. So you can do a.collect, right? Now, Another interesting point. Remember, I told you that whenever you're creating an RDD, right, it will divide the data, partitions, right? So when you're reading from Hadoop, this is easy because in Hadoop, what your Spark will do, it will treat each block as a partition. So if your data is divided into, let's say, 10 blocks, Spark will create an RDD with 10 partitions. No doubt about it. But right now, my data is not in Hadoop. When I say 1 to 1000, the data is not in Hadoop. Okay. Um, so the question is that in this RDD called A, how many partitions will be there, right? So we will look into that. You can also create other RDDs. You can say sc dot parallelize, okay, and then you can say I have a list of elements like Hadoop, Spark, MongoDB, Python, Scala. So again, here I'm creating an RDD. So this is my data. It's a Scala list. And I will again call the sc.parallelize method on that, right? And I get the RDD. And if I do a b.collect, I have the data. No rocket science, something very simple, right? So let's again run the a.collect. Okay. Now I want to know how many partitions this RDD is having. So you can simply do a dot partitions dot length. And when you look at the length of partitions, it says 2. So Spark is telling me that there are 2 partitions for this RDD. And I will tell you why. And you can see that in the shell. So if you refresh the shell, the UI, you see the Spark jobs. So you see 3 collect statements, okay, that we ran. And this is the latest collect statement. And if you look at this collect statement, okay, it says 2 by 2. Can you see here a number 2 by 2? So the first 2 indicates the partition, the next 2 indicate the task which we're running. I mean, what Spark is saying is that there were 2 partitions for the data and your task run on each partition 2 times actually. So the default number of partition in here is 2. The question is that why it is dividing your data into 2 partitions, right? To answer that question, it's very simple. If you look at my VM, this is my VM. So I am having 2 processor cores, and that is why it is creating 2 partitions, okay, of my data. Now, the more partitions you have, the more faster your program will run. The idea is that the more partitions you have, more faster your program will run. Ideally, what will happen? Each partition will be, when you run the program, right? A processor core will be allocated to each partition. So if I create only one partition, only one processor core will be allocated for the whole data, and it will be very slow. So in real time data, so your data will be spread across, let's say, 20 machines or 30 machines. So each machine will hold a partition, and the more partition you have, the more faster your program is going to run. Okay, so this means the number of partitions are 2. We understand that. But the next question comes, is there a way I can change this? By default, it is 2, but can I change the number of partitions? And yes, you can. If you want to change the number of partitions, let's say you want to create a RDD with 10 partitions, do like this. So all you need to do is an SA parallelize 1 to 1000, comma 10. See? And then if I do a dot collect, sorry, a dot partitions dot length, you see it is 10. And if I do a dot collect, I get my data. The data remains the same, but while creating an RDD, you can manually mention the number of partitions as well. This has to be done by considering the resources in a cluster. As of now, don't worry about manually mentioning the partition because we will not be doing that. We will leave this thing to Spark to figure out the number of partitions. That is the best way. But in some of the advanced programs and conditions, you might want to tweak the number of partitions, which you can do. That is what I wanted to show. And if I look at the Spark UI right now, you see this job is having a 10 by 10, right? So this indicates it was running, with 10 partitions. And clearly have a look at here. Look at the duration, the time taken to run the program. Do you see anything interesting there in the duration? The more partitions you use, the faster your program will run, ideally. Okay. So when I was using 10 partitions, it was 0.1 because, it's like parallel processing, right? So it becomes faster, ideally. But anyways, we are just not interested in that right now. I will exit the Spark shell. Okay. Now, how to start this Spark shell in the yarn mode, right? So we have this yarn mode, right? So the local mode, you know how to start. You simply type Spark shell. In order to start Spark in the yarn mode, what you need to do is that you have to say Spark hyphen shell hyphen master yarn hyphen deploy mode client. So this is the command. I'll just copy the command. I'll write it here probably. To start Spark in yarn mode, use this command. So what is this command? You will say Spark shell, that is same. You will say master is yarn, deploy mode is client. That is how you start. And same thing will happen. I mean, the Spark shell and all will remain the same. The commands also will remain the same. But this time, the Spark shell will register with your resource manager. I will show you that. Let it start. It's taking some time to start. See, comparing with the local mode, it is slow because yarn is actually slow, right? You are using the resources allocated by yarn and it will be very, very slow since you are running in a VM. Okay, Spark started. You can see the shell, and here you can see that Spark context is available as SE and master is yarn client. Previously, master was local. Now it is yarn client, which means it is running in the yarn mode. Now, in the yarn mode, if I look at the UI, I will not see the UI. So if you type, okay, so this is redirection, okay. So in the yarn mode, if I want to see the UI, okay, what I need to do is access your resource manager. So this is the Hadoop resource manager, and I think you are aware of this. I'm aware of this, right? The Hadoop resource manager will be by default running in port number 8088, and look at the application that is there using it. The application name is Spark Shell. Can you see here? Application type is Spark, and if you click on this application ID, okay, you have this application master. Remember in Yarn, when you launch a program, it will create something called an application master. If I click on this application master, I have the Spark UI. So the point is, when you start this Spark shell in the Yarn mode, it will register with your resource manager. That means you have to open the resource manager UI to see Spark. That's what. So now the next question is that the one way to create an RDD is from a collection. The second thing is that you can create an RDD from an external file, and probably this is something which you need. So let's say you have a file, a text file or a CSV file or any file that you have. Probably you want to create an RDD from the file. How can you do that? Here we will be using a method called text file. So text file is a method we use to create an RDD if you want to read from a external file. So to show you that, what I'm trying to do here is that I will access my Hadoop. I will start my Spark shell. So I will access my Hadoop, and if I go to my Hadoop, there is a file called a book.txt. Let me show you that. Okay. So there is a file called a book.txt. I'm just highlighting the file. It is a book actually, some book. I don't know even what book it is. Now, what if I want to create an RDD from this file? Right? Very simple. All you need to do is let it start. Come on. All you need to do is that simply say something like book equal to sc dot text file. That's a method. And then you will say simply book.txt. Why am I typing only the name of the file? Because it is in my home directory in Hadoop. Otherwise, you have to give the complete path. Since it is in my home directory, I just have to give only the file name. So you simply say sc.text file and then the file name. It will create an RDD. Give you this command. And when I do a book.collect, it shows the result, right? Again, it is displayed inside an array, but we can clearly see some lines from here. Okay, so that means we are able to get it. Now, collect is one action, right? What are the other actions you can run? You can do a book dot, okay, first. Can you tell me what this command is doing by looking at the output? What will this action do? Book dot first. Exactly. It will read the first line, right? It will read the first line. Now you can also do a book dot count, and it will count the number of elements in the RDD. So here an element is a line. So it's counting the number of lines, 12,760 lines. You can also do a book dot take and a number. So first, count, take, all of them are, all of them are actions. Now, one more thing that people are always asking is that, okay, I want to collect, but how do I save the output? If you want to save the output of an RDD, you can do many ways actually, but the easiest way will be to save it as a text file. So what you can do, you can say book dot save as text file. This is the method, and then simply give a folder name. What will be the folder name? Something like this. So this command will save the RDD, okay, in a folder called ABCD. ABCD is the folder name. And where is this folder? It will be in Hadoop. If I go back to Hadoop, user, cloudera, there is ABCD, and here is the output. but it is storing as 2-part files. And this is actually the book. There is some formatting issue, but you can see here the actual book, right? So yes, you are able to save it. Okay. Why 2-part files? Because you are running 2 partitions. Each partition will save its own data, and that is why you get 2-part files in here. Word count problem using Spark. So first thing that I have to do is I will be using this book.txt, the data set that we have. Where is it? So we have this book.txt, and like I said, it has around 12,000 lines of data. So I thought that this will be a nice input file for running our word count program, right? So we will use this as our input data set, and then we will see. Okay. And the first thing you need to do is create the RDD. So I will type it again. Book equal to so step number 1, read the data and create the base RDD. What do you mean by base RDD? That is the first RDD you will be creating in any Spark program. And this is our base RDD. Okay. And we will just ensure that we can see it very well. So it's working fine. If you look at my RDD also, this RDD has lines of data. For example, this is one line of data. Where is it? So this is one line of data, or probably this is another line of data. So this is the first line of my data. The project Gutenberg ebook of the outline of science. That is my first line of data. And what I should do, I cannot do anything with a line of data. I have to get the individual words first. First thing you need to do is that you have to extract the individual words. And remember the map transformation we were talking about? Probably the map transformation is a good way. So let's say we create an RDD called A, where I will do a book.map. I will say that take every line and split it using space. Now this command should be familiar to you because we have already seen the map transformation in Scala. So the same map transformation can be used in Spark. Map is a transformation actually in Spark. So what I'm telling here is that, hey Spark, take the RDD called a book, apply the map transformation to every element. An element is a line, right? And I'm taking that, take every element X. X is a line, split the line using space. We are assuming that the delimiter is space, and that's it. So ideally, you will expect that if you do this, you will get each line and the line will be having individual words. So A is my RDD, which contains the uh, individual words, which should ideally contain the individual words. But when I do a dot collect, the problem is it took one line. Look at the first line, the project Gutenberg ebook of the outline of science. So this is the first line. It took this line and it extracted all the words. See here, it extracted all the words. Okay, like this. Okay, I think it is still volume 104. So this is one line. It extracted all the words. You can see the, then project, then Gutenberg, then ebook. But the result is stored in an array. So we have an array of arrays. That is not really good for us. Since the map transformation will work on individual elements, that means individual lines, for each line, the output will be an array. And all of this you are doing in an RDD, so there will be an outer array and list of arrays inside them. That means from this, right, it is difficult to get the individual words. All I want is words. That is why you should not use map in such scenarios. I just showed you a map to tell you how the output will look like. Ideally, what you should do is that you have to do a flat map. So look at what I have done. Instead of using the map transformation, I am now using another transformation called flat map. And you will understand what is flat map if I show you the output. If I do a dot collect now, look at the difference. Do you understand? Just by looking at the output, I think you will understand. So what is flat map actually doing? It will flatten your result so that you will get all the words in a single output. So now we are happy because we got the words here, right? So I will just write it here. This is your second step. Okay. Second step is extract individual words, and you will do it like this. Okay. So now remember this point, you have an RDD called A, and in the RDD called A, you have all the words. Okay. RDD A has all the words. Look at the anonymous function I have written. So here it can be anything. It can be X, Y, Z, J, anything. I'm saying that take every element and convert to something like this. Probably if I do a B dot collect, you will understand. Just look at the output. You are taking each element or each word and converting that into a key value pair. I mean the word comma 1, right? So if I write it, fine. So we have reached till this point. Now the final stage. I will just write it, then I will explain. Don't worry. So I did something, whatever it is. I did a command, b reduced by key, blah, blah, blah. But if I do a c dot collect now, I have the final answer. See, this is repeating 28 times. Iron is repeating 20 times. Constant is repeating 2 times. Born is repeating 3 times. Whatever I did in the RDD called C, I have the final answer. But the question is that what did you do? So step number 4 is get the final answer. And to do that, I have typed this. Okay, so this is the command I typed, and I will explain what is this command. I will explain what is this command. Okay. So this is a very interesting transformation. It is called a reduce by key. Okay, the transformation is called reduce by key. Now what you need to understand is that by default, when you use reduce by key, it will assemble all the values of a given key. Okay, so what am I saying here? I am saying that if you use reduce by key, it's going to assemble all the values of a given key. So let's suppose our data in B was like this. So B was our original data. So let's say the data was this comma 1, this comma 1, this comma 1, and this comma 1. Okay. So the original data in B, okay, the original data in B was like this. Okay, this one, this one, this one, this one. Imagine. Okay. Now you are saying that reduce by key. So reduce by key will assemble all the values of a given key. This is like the shuffle phase. In Mapreduce, you have a shuffle phase, right? In shuffle phase also what happens, it's gonna get the key and values similar, right? And in here, you are writing a very special anonymous function. You are saying that x comma y rocket symbol x plus y. This is what you have written. Okay. So what is the technical definition of this? Here, x and y are any two values. So we have four values, 1, 1, 1, 1. X and y are any two values. The expression says take any two values x and y and add them. Also, keep on doing it till the values are over. So to make you understand, this is a special way of writing the anonymous function. We say x, y, x plus y. This simply means take any two values and add them together until the values are over. What is going to happen? Your values are like this, right? The values are 1, okay? Then you have 1, then you have 1, then you have 1. These are the four values, right? Now, initially, x will be this and y will be this, okay? Now, what will happen is that you are saying that take x and y, do x plus y. So, if I apply this logic here, if I apply this logic here, I will get the result as 2 because 1 plus 1 is 2. Okay, and now your data will become like this: 2, 1, 1. Okay, and now your x will become this and y will become this. Again, you will iterate the expression, right? So this expression will run till your values are over. Okay, I will get result as 3. And now your values are changed. You will have 3. Okay, so you are adding 1 plus 1, 2, 1, 1, then 2 plus 1, 3, and 1, right? Again, x will become this and y will become this, right? And again, you iterate through this. I will get 4, meaning you will finally get this comma 4. And since this will run for every key, you will get the final word count. So you can also say something like this. For example, you can say x comma y, do this. Okay, you can say x divided by y. So this is another expression. If I run this expression, it will keep on dividing. It will take the first two numbers, divide them, and the result again it will divide by the third one, It will keep on doing division until all the numbers are over. Right? We were adding, and you can also do division, you can do subtraction, you can do anything using this expression. But this is how the expression works. So I will get the result, and obviously, one more point is that you can do this. For every x, you say convert to x comma 1 dot reduce by key, and then you can say take the values and simply add them together. That's word count in a single line. This is single line, entire word count program. It's easy in the way like first of all, the size of your code is very less, right? So that is the first thing, right? The size of the code is very less. And also running that is also faster. Obviously, Spark is faster than Mapreduce, right? Remember, you used to run the word count program. You'll create a jar file, deploy it, and even if your data is very small, it will take a lot of time to run it using Mapreduce. Okay, so that is one thing. Now, one more point in here is that even though the data looks really nice, okay, even though the data looks really nice, we have some problems. The output is okay, but we have some problems. What is the problem? For example, if you look at this p-value pair, it is saying that influences dot is a word, which is not the word, right? The actual word is influences, but since it is separating each word with space, it is counting influences dot as a word. And again here, if you look, it is counting vendor semicolon as a word, which is not really good. So can we make the word count program a little bit better? Yes, you can do it. What you need to do is, you can use a regular expression. So this is a regular expression I am using. I am asking that split it using proper words. And as you can see, the results are sort of much more refined or cleaned, right? So they are not like previous. The results are sort of like more refined. Your encyclopedia and all are gone, I believe, right? Because there was some special character, I think it will get rid of that, right? But apart from that, it looks very nice. Still, there is a lot of cleaning that has to happen. For example, there is a word called underscore Jurassic underscore. See here? So this word is bad. But let's forget that for the time being. If you get rid of the underscore, the rest of the things are kind of like happy, right? So the results are clean. Word count with regular expression is this. Okay, so this will be much more cleaned up. And now we have lot of what you say transformations to look at, but I will just stick to one more important transformation because that will be useful in this problem. So what if I want to sort the output? Sorting, right? What if I want to sort the output? Okay. So if I look at the output, it's a key and a value. Okay. You can sort based on the key. You can also sort based on the value. However, if you're doing this, we will use a special notation so that you will understand, right? The sorting side, right? So first thing I'm going to do is that I want to sort it based on the key. Okay. So what is the key here? The key here is the word. So I want to sort the data based on the word. And when you sort based on the word, it will become alphabetical, obviously, right? And in Spark, when you do sorting, the default is ascending. That means A, B, C, D up to Z. You can also do descending, okay? But the default sorting is ascending. So I will write it here. Sort the output based on the key. That is a word we have, right? Well, that's okay. But the real question is that you can say sort it, but how do you tell Spark that you have to sort it based on the key? So my question here is that what is an element in this RDD? So by looking at this RDD, so this is the result, right? This is the RDD. Can you tell me what is an individual element in this RDD? What is an element in this RDD? We say this RDD is a collection of what? Key value pairs, right? So this RDD is a collection of key value pairs, correct? So an individual element in this RDD is a key value pair. This is a key value pair. Intimately, comma 2 is a key value pair. Okay. So an element here is a key value pair, obviously, means this RDD is a collection of key value pairs. And that's something you have to understand. Okay, no doubt about it. Now you have to say, okay, sort the data based on the key within the key value pair. This is what you have to tell Spark. You have to tell Spark that, hey, Spark, access an element first, and within the element you have a key and sort it based on the key. So you will tell that so the element is simply key value. Then within the element, okay, use the key to sort. This is what you have to tell Spark. Now, in order to do this, I will write the code, then I will explain. I will say that sort by underscore dot underscore 1. Answer is there. I will copy the code. This is the code I wrote. Okay. The thing that I added here is sort by. So sort by is a method we use for sorting. But I used a special notation after that. I said underscore dot underscore 1. So this is what I used. And this is something which is a bit confusing. Okay. Here The first underscore means an element in the RDD, which is nothing but a key value pair. The second underscore means, okay, an element within the key value pair. Okay, so underscore 1 means the first element in key value pair, that is the key. So when I say underscore dot underscore 1, first underscore means an element in Spark RDD, that is nothing but a key value pair. So I am saying that access a key value pair, within that dot underscore 1, within that the first one, that is the key. Basically I am saying sort by key. Well, functional programming can be a bit hard for the first time to understand, but yes, right? So you are saying that take a key value pair, any key value pair, and within that access the key, and based on the key I want to do sorting. That is what you are saying. And if you look at the output, okay, you are getting these numbers, because in the ascending order it starts with numbers, then only come A, B, C, D. And if you want to do descending, all you need to do is that you will say underscore 1 comma false. See, you will say underscore dot underscore 1 comma false. When you say false, it will say descending order. And as you can see, it starts with Z, zoo types, then zoologist, you, yolk, blah, blah, blah. So this is descending order. Sort by key in descending order will be this. So same thing, you will say sort by key false. False means descending order.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.